Okay, so I knew that Charles was going to spend his the time looking at things in the sky for the autumn. So I thought, well, it probably wouldn't be a very good idea for me to focus on what's going on in the sky because that would kind of overlap with what Charles was talking about. So what we're going to talk about actually is some few little things that you can do with stellarium that are kind of relevant to this particular season of the year. Now, you all know that I have this kind of fetish about the equinoxes and the solstices, and I'm always trying to find out exactly what's going on there. So I want to just kind of review what we're talking about and illustrate some things using stellarium and carte du ciel. My apologies for French. I think I will call it Skychart from now on. So equinox means equal night, i.e. the day and the night are of equal length. So if we take a look at Vancouver, September the 25th, 2001, you'll see that sunrise is at 7:03 and sunset is at 7:03 p.m. So that gives us a day and night of 12 hours each. However, if you take a look at the equinox, it is the published equinox is September the 22nd at 12:21 p.m. Pacific Daylight Time. Well, and on that day, the sunrise is at 6:59, sunsets at 7:09. If you add that all up, that's the daylight is 20 minutes longer than night. So it's not an equal night. So what's the problem? Well, basically, there are two problems. Number one is that the sun is about a half a degree wide and takes a couple of minutes or more to rise or set. So basically, if you thought of the sort of equal day and equal night, sort of you'd say, well, when this half the sun is up, then that's the start of the day, and when half the sun is set, and that's the night. But of course, that's not the way it works. And the other thing is that the atmosphere of the Earth bends the light rays from the sun so that we can still see it when it is below the horizon. Now, according to my screen, by the way, gentlemen, at this time, I've got a bunch of, is that what's going on here? Okay, okay. So that's basically the two problems. So I wanted just to carry on here, and what I'm going to show you here is sunrise on the equinox. So this is September the 22nd from Sept, and I'm using stellarium. So the time just starts ticking away. It's going a little faster than it should. And you will see the sun start to come up, and it actually breaks the horizon at 7:02:04. So 2 minutes and 4 seconds past 7. And then it rises, and you'll notice it's very distorted. It's wider than it is tall, and that again is a feature of atmospheric refraction. And it finally clears the horizon at 7:05:19. And then it carries on, and it goes past the point where it is due east. And we'll just let it go for a little bit longer and just park it somewhere up here at just an arbitrary time that I selected, 7:08:55. So 8 minutes and 55 seconds past 7 o'clock. Okay. Now, there is a feature on the stellarium which allows you to remove the atmosphere. So let's do that. Basically, we're just going to just flip a switch, and it clicks off the atmosphere, and that's what happens. So the sun dropped quite a bit, and this is where it actually is on this at 7:08:11. Okay. No. Okay. So now what we're going to do is we're just going to bring it backwards. So that it half up and half down. And this is at 7:07:11 a.m. Now you'll notice it's not directly in the east, and you might think, and it's a pretty reasonable idea to think that on the equinox, the sun will rise exactly in the east. Now we've got no problems with the atmosphere distorting the position of the sun. So this is the way it would be with no air. And yet you'll notice that it isn't rising due east. In fact, it's displaced a little bit over. And we would say that it is rising slightly north of east on the equinox. Okay, so let's now flip over to the west. And in fact, what I've done is I've gone exactly 12 hours from the last screen. And so this is 7:07:11 p.m. So that's pretty good. It's actually sitting about halfway up from on the horizon. But notice it's displaced, and it's displaced slightly south of west, which is, well, I guess that's what you would expect, right? On the day that the equinox occurs, it's going to cross over the equator, so that by the time it's, so if it rises slightly north of east and sets slightly south of west, then it's crossed over the equator, which is, of course, the whole idea of what it really means for it to have the equinox. It's when the sun crosses the equator. Okay, so now this is what happens if you turn the atmosphere back on. And so that's, you know, kind of in midair. And this is what it would be if you have it half sunk. And when it finally disappears, it's at 7:11:49 p.m. So the total day length is 12 hours, 9 minutes and 45 seconds, which is, well, there's your 10 minutes. 10 minutes longer of day, 10 minutes less of night. And so that's why we don't have equal night on the day of the equinox. Now, precision. As you know, I'm a fanatic about precision, about these things. And so when does the center of the solar disk actually cross the equator? So it's when the celestial latitude, or the declination, technically, of the sun is 0 degrees. So what I did was I took Skychart and I set it for the Sept Observatory. Then I selected the sun as the object of interest, and I ran a time simulation on the day, in fact, close to the to noon on the day of the September equinox, until the declination of the sun was as close to 0 exactly as I could get it. Well, the time was 12:13:42. Now the published time is 12:21. So there was clearly a problem here. So that may be a bit suspicious. So what I did was I said, well, I'm going to check at the equator directly south of Sept. So I went south of Sept, and yes, that was a large part of it. The declination was greater than 0 when you were sitting on the equator. So, of course, what I then did was I advanced the time until the declination at the equator was 0. Okay, so why is this? Well, it's because when the sun is directly above the equator, it looks like it's below the equator from 49 degrees north. And so, for instance, if this is the Earth and this is the equator, and somebody at the equator is looking at the sun, obviously this is not to scale, but they're looking at something directly above them, and then they project that back on the celestial sphere at the infinity. Now, somebody who is sitting at 49 degrees, they look at the same object and they project that back to the infinity, and of course it's below the equator from that vantage point. So there's an angle here, and that angle was 6.6 seconds of arc. So that's 6.6 divided by 3,600. That fraction of a single degree. That was the difference between the declination, according to Skychart, from 49 degrees north Sept to the equator. Well, we know that the distance to the sun is 150 million kilometers. So using that angle and a little bit of math, you're able to calculate what that distance should be. And what I got was 4,800 kilometers, which is pretty close to the 4,830 kilometers that it actually is. That's not along the curve of the Earth, that's straight through the Earth, 4,800 kilometers from the equator. So Skychart is so precise that it will tell you that the declination of the sun differs from and different parts of the globe when you're looking at a nearby object such as the sun. But of course, when you're looking at the stars, then that's another question. They're not going to be distinguishable from different points on the Earth. Okay. So basically that tiny difference, the reason why when I got to a 0 declination from Sept that it wasn't the exact time of the equinox was because it was a difference in perspective, a distance of 4,800 kilometers. Okay, so it turned out that the time of the 0 declination at the equator was 12:20:32. So that's to the closest minute, that's 12:21, which is the published time. Where is it directly overhead? Well, as you can see, it's pretty close to noon in our area, 12:20, actually, because it's Pacific Daylight Time, it's actually a little bit before noon, local noon. So here it is, to cut to the chase here. This is out in the ocean, and it's the nearest island nearby is the Clipperton Islands. And so thinking in terms of taking a visit, I looked up, and I have it on good authority that there is absolutely nothing of tourist interest on Clipperton Island. The only reason people have ever gone there is to dig out the guano, which is there and been laid there by the birds. On the other hand, there's the Galapagos, and this is such a tourist hotspot that you have to be on a waiting list for years before you're even allowed to go there. So that's also out of the question. So I thought of a better idea. I said, look, clearly this is not a good place to visit. So why don't we visit a place in Canada, which would be directly north of this zone here, so that the sun would cross the meridian at that point, just at the equinox. So here we are. And you can see there's a little spot there that marks the September 2021 equinox. And this is Drumheller. Drumheller has a world-class dinosaur museum, so you could take that in on your trip. And then the night before, you could stay in the delightful little hamlet of Hannah. I've been there. And then around noon the next day, you could head 4.86 kilometers west of the intersection of Palliser Trail and Highway 9. And at 1:20:32 p.m. Mountain Daylight Time, September the 22nd, you would witness the equinox as the sun crossed the meridian at that point. So have fun learning about the sky and stellarium and Skychart. If you haven't checked out, Skychart, by the way, I used it because it's reputed to be more accurate, and certainly I found it to be so in checking the equinox. And both of these programs are free. And that's it for today. There you go.
Thank you. That's much better than traveling halfway around the world to the other equinox that you were talking about last year.
What's that? Yes, right. Well, I thought, like Drumheller, that's doable. You can jump in your car and get there. Yeah. So we're lucky. It's going to be right, in the middle of the sky when the equinox happens. But yeah, it's a bit tricky to use these computer programs when they're so accurate that, you got to take into account where you are on Earth as far as the angle to the sun.